Hello, this is the section 8.3 notes on bonding theories. So the learning goal for this section, there's just one, use Vesper, V-S-E-P-R theory, to predict the molecular shape of a molecule based on its structural formula. And with Vesper you have different shapes. The ones that you need to know are trigonal planar, trigonal pyramidal, bent, linear, and tetrahedral. And the terms are just Vesper theory, what that means, and then those different shapes that I just mentioned. Okay, so Vesper theory. Vesper is an acronym. It stands for valence shell electron pair repulsion. Okay, so that's a theory that scientists use to help explain the three-dimensional shape of molecules. And it works with the idea that in a molecule there's electron pairs, and those electron pairs they all have negative charges. Electrons have negative charges, so they want to repel each other. So they want to get as far apart from each other as possible. So electron pairs, whether they're bonded or unbonded pairs, will repel each other, and the molecule shape will adjust to keep them as far apart as possible. So the three-dimensional shape is set up so those electron pairs get as far apart from each other as they possibly can. And that leads to the different shapes of the molecules that we have. And then there's also the fact that unshared pairs of electrons strongly repel bonding pairs. So unshared pairs of electrons are free to move around more, so they end up taking up more space. So they're going to push other bonding pairs a little bit closer together. All right. Okay, so these are the different shapes that you need to know. So you'll want to write down the name of each and then draw out these different structures. You'll want to draw out the Lewis dot structure as well as a shape, the molecule shape right here. Okay, you want to do that for each of them. At the end of the notes for this section, there's a table that summarizes all of these, so it'll all be put together. All right, so with a linear molecule, it's just going to form a straight line of all the atoms that are involved. So carbon dioxide is an example where you have this carbon in the middle, and then these oxygens are 180 degrees apart, so they're as far apart from each other as they can be. All right, so that's a linear molecule. There's also a linear molecule if you just have two atoms in the molecule, it's going to form a line. 2 points can only make a line. So that's another example of a linear molecule. The next one is trigonal planar. All right, with a trigonal planar molecule, you have three atoms bonded to the center atom, and there's no lone pairs on the center atom. So that's a trigonal planar shape. All right, and here's a picture of it, three-dimensional picture of it right there. But this is what the Lewis dot diagram looks like. There's three atoms bonded to the center, no lone pairs on the center. Next is bent. Water is a good example of a bent molecule where you have two atoms bonded to the center atom, and you have either one or two lone pairs of electrons on the center. Like in this case, oxygen has two lone pairs. All right. The dash, if you think back to Lewis dot diagrams, the dash represents a bonding pair of electrons. The dots represent a lone pair of electrons. All right. So with bent, we have two bonds, and we have either one or two lone pairs on the center. Okay. Water's an example of that. The next one is trigonal pyramidal. With trigonal pyramidal, you have three atoms bonded to the center atom, and you have one lone pair of electrons on the center atom. And this forms, if you draw this out, it forms kind of like a flat pyramid of the atoms, okay, where that center atom is up a little bit, okay? The next one is tetrahedral. So tetrahedral is when you have four atoms bonded to the center. So this shape allows the atoms to get as far apart from each other as possible. So they take this bond angle, it's 109.5. Now we don't need to know bond angles, but that's the angle that allows those outer atoms to get as far away from each other as they can. So tetrahedral is when you have four atoms bonded to the center with zero lone pairs on the center. All right, and here's the table that summarizes all that. So what you'll want to do to figure out the Vesper shape is it starts with the Lewis dot diagram. So you'll draw that out, and then you look at the center atom to see how many atoms are bonded and how many lone pairs of electrons are on the center atom. And then you can use this table to tell you what the shape of that molecule is. Okay. All right, so copy this table down, and then that's the end of the notes for this section. Have a great day. Bye.